So here we go. This example here will take us through how to solve a trig equation where we've got tan. But ultimately, it is the same process as we do for sine and cosine. So we start, step one, I suppose, is, well, I guess preparation work before step one is to change our tan function so that we're solving a related problem which is simpler to solve. And that is by going tan theta. Oh, I'll just change to the right color. Sorry. Okay. Tan theta is equal to negative root 3 on 3. But because we've now changed from x to 3x to theta, I need to adapt my domain. So I'm now going from negative 3 pi to 3 pi. So that's my new domain. So again, if I can find all the solutions for theta between negative 3 pi and 3 pi, then I can solve the original problem of what is x. Okay, so the other thing I'd like to point out is I'm going to reintroduce the theta hat notation, because I think, in a way, every time I've said consider it in the first quadrant, I think that's almost a bit of a confusing message, because in this instance, for example, there is no first quadrant angle. So instead, I'll just say what we do is we consider the ratio without the sign, so root 3 on 3, and we say, what would the acute angle be that when I apply tan to it, I would get root 3 on 3. So that's what theta hat is. It's basically the value that you get from looking it up in a table or from drawing a triangle and figuring it out. So when we do that, we'll see that root 3 on 3 is equal to pi on 6. So there we go. Pi on 6 is what theta hat would be. It's the angle. It's the angle that if we applied tan to it, we would get root 3 on 3. However, root 3 on 3 is not positive, it's negative, and so we need to consider in what quadrants tan is negative. And we know from all students, oops, it'd be useful if I actually start on the right quadrant myself. All students take care. We know that tan is negative here and tan is negative here. So it's these two quadrants that we need to be aiming for. Now, this is the thing that I thought it might be helpful for it to make sense. In part one, we've got where's Wally here. And by that, I mean, where are we going to be looking for our angles? We know it's pi on 6 at its acuteness, but where is it going to be? And what I suggest you do is you split up your hunt for these numbers into negative angles and positive angles. So if I look at between negative 3 pi and 0, when I look at my my cast diagram here, negative 3 pi and 0 would look like this. So if this is 0, kind of, and I go backwards, I start here, I go round to negative 2 pi, and then I go round again, and this would make me stop at negative 3 pi. So that's the full rotation from 0 to negative 3 pi going in, I'll put it at the end actually for a reason I'll make sense later. It goes around in that direction, okay? So it starts there and spirals around. Now, if you have a look at it, tan is negative here and tan is negative here. So if I have a look at my little spiral here, that means you can sort of see that I'm going to get two possible solutions in this quadrant, around once and around the second time, and one possible solution in quadrant 2. Okay, so in this quadrant, one possible solution, you can see that it spirals, it hits there once, and two solutions there. So that's where Wally is. Let's have a look at the other quadrant. Sorry, not quadrant, the other way. So for theta being between 0 and 3 pi, so that is our positive angle. if I now draw my cast diagram here and start spiraling, this time I'm going to go counterclockwise, which is what a positive angle is. So I start here and I go 0, then around to 2 pi, and then around to 3 pi, and I finish there. So it's in that direction. That's for positive angles. And again, you can see that I should have 2 solutions up here in this instance and 1 solution down here. So I'm looking for 6 solutions ultimately in that sort of pattern. Good so far? I hope that makes sense. And that way you sort of already know what you're aiming for. You should get 6 solutions and you know which quadrants they're going to come from. The rest of it is trying to figure it out, which is part 2, right? What's Wally? So Wally in this case is going to be the possible values for theta. Okay, so what I'm going to do now is I'm going to show you the shorthand way of thinking about it. So you might need to just be prepared to keep up with what I'm doing visually and vocally, rather than just looking on the board, because it really won't make much sense just if you don't even look. So I'm looking for values of theta. I'll just go to the black pen. I'm looking for values for theta, and I'm going to do it in order. Now, in order would be from negative 3 pi all the way up to 3 pi, right? So I have to look at the most negative value first and work my way up. So looking at where's Wally, here are my negatives. This is negative 3 pi. So I'm going to work back to my first blue dot. My first blue dot is in this 4th quadrant, and it's heading to, going backwards, it's heading towards negative 2 pi. So I'm ignoring anything here. I know there's nothing here because tan is positive. So my first point of reference is here. And it is going to be negative 2 pi plus another negative pi on 6. Okay, so what you need to do in your head, and this is where it's not going to be written down right, is go, well, negative 2 pi is negative 12 pi on 6. I'm adding another negative pi on 6, so I end up with negative 13 pi on 6. I'll just write that again, that was dodge. Negative, oh man, even more dodge. Negative 13 pi on 6. That's our first one. That's our first blue dot covered off. Keep moving. Okay, nothing in this quadrant. Here's my next blue dot. This blue dot is heading towards negative pi, but didn't quite get there. Okay, so it's going to be less than negative pi. So it's going to be negative pi plus another negative pi on 6. So negative pi is negative 6 pi on pi. So if I'm adding another negative pi on 6 to it, I end up with negative 7 pi on 6. Yeah? Again, I'm not putting those fraction calculations down, so it's really hard to see. If you look back on these notes and you say, well, how did you get these numbers again? You're going to have to go to the video, right? Awesome. We're nearly there. We've got almost half of them done. So we've done that one, and back to here, knowing that we're almost back to 0 here. So this dot here is 0 plus a negative pi on 6. And so it's just negative pi on 6. There's our first 3 done. How cool is that? So using those, what I'm doing is I'm almost dividing your thinking down. I'm saying in this part, think about what the acute angle is and think about where we're going to come across the negative of that acute angle effectively. Here, I'm saying, well, what does that look like? So unloading my thinking here. And then lastly, I'm now saying, well, what does that mean? Which is the what's Wally question. Okay, let's do the positive ones. It's all theta, so I'm just going to keep on putting commas in. In this direction, I'm now moving forward. It's a bit more easy to get your head around in a way. So moving around my spiral, here's my first blue dot, and my blue dot is heading towards pi. So this blue dot is going to be pi minus pi on 6. Now, pi is 6 pi on 6. So 6 pi on 6 minus pi on 6 is 5 pi on 6. Okay? Keep on going. Round my spiral. I'm up to here now. Here's my next blue dot. It's just short of 2 pi, that first full rotation. So 2 pi minus pi on 6 will get me this dot. So we've got 12 pi on 6 minus pi on 6 is 11 pi on 6. So 12 pi on 6, 2 pi, minus 1 pi on 6, pi on 6, gives us 11 pi on 6. And again, moving my way through the spiral, done that one, final one before I get to 3 pi, and that is this one here. So this is going to be 3 pi less pi on 6. So 3 pi on 6, so 3 pi is equal to 18 pi on 6. 3 6s are 18. So 18 pi on 6 minus pi on 6 is 17 pi on 6. And that's that done. And what we also know is all of this equals 3x. Why? Because that's the relationship we had here. 3x is equal to theta. So the next step, theta, to be fair, is a fake Wally. It's like the red and white stripes have been inverted or something like that. Then that's not actually Wally. That's actually the fake Wally. The real Wally is x. We know that each of these values, which we worked out to being theta, is actually 3x. So all we're going to do now is we're going to divide each of these values by 3. And PS, that's effectively multiplying the denominator by 3. So we end up with this. Therefore, x is equal to negative 13 pi on 18. Yeah? All I've done is I've taken the denominator 6 and I've multiplied it by 3. Okay, that's the equivalent of dividing both sides by 3. If you don't get that, ask me later. And then I'm going to do the same thing to each of the others. You'll see the numerators are not touched, but I'm just changing the denominators to 18. And, oops, that is the end. Okay? So again, just to repeat, just to summarize that process, and then I'll let you practice to your heart's content. We start off with restating the problem as sorry, I just saw that. Restating the problem in terms of theta and reordering our domain. We then look at theta hat, the acute angle, which would give us the unsigned root 3 on 3. We then work out which quadrants the signed root 3 on 3 would give us. It's negative, so it's here and here for tan. We then go and work out where in the domain we are going to find an angle. So that's what negative 3 pi looks like. So therefore, I'm going to get 1 there and 2 there. This is what 0 to 3 pi looks like. So we're going to get 1 here and 2 here. We then translate these blue dots into actual angles. And then, in this case, we're going to divide by the value in front of x in order to get the actual set of values for the original domain. The domain was negative pi to pi, and you can see these values definitely fit between negative pi and pi, and hence we can drop our pen. Okay, I'll stop the video, but then I'll ask if anyone has any questions before I let you loose on the problems from the textbook.